All right, guys. I'm gonna go ahead and unfreeze this now. Could someone get the lights for me? Stevie, namely. Okay. It used to be Emily, but Emily gets to take a break today. Okay. All right. Is this what you guys sort of got? Mine's definitely not perfect, but in other words, what graph is that, or what's that? We start with the function of the sine of x. What is the derivative d? The derivative of f with respect to the variable x. What was that equal to? That blue line. It is actually that blue line is, we'll say f prime of x. That is the cosine of x. Would anybody like me to go through with how you got that, or how it should have been constructed? Okay, I'm gonna go ahead and do it like from scratch. So first, let me build the sine graph. As review, does anybody remember what this? If this is just a standard sine graph, what are these y points? The minimum, the maximum, and minimum value that this sine graph can go up and down and oscillate between. 1 and -1. Very good. How about these increments? Does anybody remember what these increments should be at where they cross, at where the sine graph crosses the x-axis? Like what? Oh, how much? How far up it goes by? I think at every completion. I believe it's a. Actually, I'm genuinely asking you now. I totally forgot. Is it pi over 2 or is it pi? I forget.
Pi, because the whole up and down is.
Hey, very good. Yeah, that's right. Because if you guys remember the unit circle, I think like from like it goes like here, it goes to pi, and then to make the full revolution, it goes to 2 pi. So it's the same thing here, pi, and then to make the full revolution, 2 pi. So we have one full cycle here. Okay. So here is where I give you a hint. Where can you tell me? Just like not even telling me exactly coordinate, like the exact coordinate, but can you tell me where the slopes are 0, the derivatives are 0 of this graph? And I know this is really uneven. This isn't actually how it should look. It's not perfect by any means, okay? But it's unique, okay? So can you tell me where can I find flat spots, or like just basically hopefully I didn't give it away, where the slope is 0? There is no slope. At which points on this graph are there no slopes? Or like there is a slope, but it's just 0. It's like a 0 slope. There's a what's it? Yeah, the maximum points and the minimum points, or increments of pi over 2 technically. So yeah, that's where it's 0. This is where it's 0, and this is where it's 0. That tells me that my derivative graph will cross the x-axis at these points. That is a really good way to start, okay? From there, once I know, because like my derivative graph is definitely going to cross somewhere. Like it's either it's going to go down or it's going to go up towards these 0 points, okay? My next question is, just after that, you set your reference points. Take a look at the slopes here. Are these slopes positive or negative? You tell me. Are they positive or negative?
Positive and negative.
So I'm going to stop you right there. Okay, so right before this point, are they positive or negative, Stephanie? They're positive, right? And they're approaching, so they're positive, right? They're really steeply positive. They're very high positive slopes, but they're approaching 0, right? So what that means is all my values on this new graph are still positive. They're in the positive region, if you think about it, okay? They're all positive numbers, and they approach a flat spot of 0. So that's why all my numbers on my blue graph now are positive, technically, right? They're in the positive region. It's just they're approaching 0 now, okay? This next spot is a little trickier to understand, but just know eventually you're going to come back up to, or you're going to come back to a flat spot, a slope of 0, okay? What are all the, so between maybe this, between on the black graph, between here and here, okay, between this 0 slope and this 0 slope, how can we describe these slopes here? From here to here. Are they positive or negative? Are they going down or are they going up? What do you guys think? Yeah, they're all negative, right? In what way are they negative? I don't know. They're just all down in this, so they're all going to be like, for all I know, it could just be like here. I'm not really good at doing this, but I know eventually it'll come back up to 0. It'll come and pass through 0. Okay. So I know I didn't draw it perfectly, but you guys should have seen that it starts sort of sort of like negative here, and it gets really steep. Okay, all these slopes get really steep, and then eventually it just kind of flattens up. So that means all these negative points, you start from like a low negative to like really high slopes, really super negative, like they get really steep right around here in the middle, and then they kind of flatten up a little bit. So that means all these negative numbers are getting smaller, and eventually you're approaching a slope of a flat spot of 0. Okay, so that's why all these values are negative all the way until it crosses the 0 point right there. Okay, again, so I know it's a kind of hard. I'm going to try to white out what I just drew there, right? But I'm going to keep the sine graph. So I'm going to keep the sine graph, okay? The sine graph's still here, right? Just pay attention to the sine graph. Okay, I'm just bolding it a little bit so you can see, okay? Now from this flat spot where the slope is 0, and then this flat spot where the slope is 0, what are the derivative slopes here? Like, are they positive or negative? I think they're positive, Mr. Wee. Oh, wow, that's really good. They are all positive numbers. That's correct. Okay, so they're all positive. It looks like, I know I didn't draw it well, but it's supposed to be like they get kind of steep, and it gets really steep right around here. It gets like the most steep right around here. So that means like at the most steep positive slopes here, you're going to hit like a max right here. So all the numbers on my derivative graph are all really high positive numbers. It's going to stop right here. That's where it's maxing out. And then it flattens out. The slope of my graphs are still positive here, but they're flattening out and approaching a slope of 0. So on my derivative graph, what that looks like is there's a bunch of positive values, right? But we're slowly getting smaller in positive values until we hit 0. We cross 0, okay? Same from this flat spot to this flat spot. That is a slope of 0. That is another slope of 0. They're all negative, so it's going to do the same thing. Sorry, it should be like, they should be having the same minimums and maximums, okay? And then from here, this is another 0 point. All these slopes are positive, and there you go. It looks almost exactly like a sister image, brother sibling image, okay? Whatever, whoever gender, sex, or whatever this is, okay? This is a sibling image to this oscillating function. This is sine of x, and then we know that kind of sister sibling image as the cosine of x, okay? If it's like if it's always like an interval behind, like an interval of like pi over 2, it's like translated. It looks like it's a translated sine graph by like an interval of pi over 2, like that, okay? Then you're looking at a cosine of x function, okay? Does anybody have any questions here? So very tough. These questions are not easy, but my biggest suggestion to you when you're approaching this is find the 0 points, okay? Find the flat spots, and then see what the slope is doing around it, okay? So on your AP exam, let's say that you have a problem, like a what do they call it, FRQ, okay, where they ask you to design a graph that resembles the derivative graph. If you don't get it perfect, they're not going to just give you binary like yes or no, like you get 0 points on this. As long as your graph makes sense, like you have the flat spots of where it crosses 0, and then they can kind of understand that this is these are positive slopes, so it's going to be kind of positive and approaching a slope of 0, right? And then this middle section is where people get really kind of crazy, like, I don't know, it could swirl for all I know, but then it approaches 0 again, okay? As long as it follows that these slopes are negative here and it crosses 0, okay? And the people grading it get a general idea of what you mean by what you're doing, then you still get a lot of partial credit, okay? You can get up to like 90% correct. If you're spot on, then you get the full amount of points, right? But if you're just still a bit off in the shape and you don't realize what you actually have is cosine of x, then you still get a lot of points, okay? All right. Go ahead and write these notes down right here. This is for you guys. Okay. So go ahead. Derivative of the sine and cosine function. We're gonna look at derivatives of functions. You guys have already done it, like x cubed, right? You can find the derivative of x cubed. Can someone do that in their head for me? What is the derivative of x to the third power? 3x to the squared, you said? Yep, 3x squared. Okay, she did that with Gray did that with the power rule, where you drag down the exponent 3 to the front. Okay, I'm just speaking vaguely here. 3 goes in the front here, and you get 3x squared. Okay, and then you have to subtract 1 from the exponent. We know how to do that with like x to the power of an exponent, right? But today, we're going to learn about the derivatives of actual trigonometric functions, okay? It's not a coincidence that I have you doing a warm-up with a trigonometric function, because it all connects. In fact, didn't you just find that the derivative of sine of x is literally cosine of x, right? You just proved it. That is your first proof in calculus. You proved to yourselves that if I actually drew out the derivative, I would get a cosine of x. So does it not make sense if I say that the derivative of sine of x is literally cosine of x? You're going to have to just trust me that if I tell you that the derivative of cosine of x is negative sine of x, it just is, okay?
No, I picked it like by looking at the tab.
Yeah. I mean,
and then I did the derivative of that, and then I did the derivative of that, and it got
did you get the minus negative sine of x when you did the derivative of cosine of x when you drew it? You did?
Well, I mean, like when I
Mhm.
drew
Nice, Stephanie. All right. Very good. Yeah.
I drew a graph that looks like the negative.
And it looks like the negative sine of x. Great. That's exactly what I want.
And then I did the derivative of negative cosine x, and that gets you back to sine x.
Now you're just blowing. No. Now you're just blowing my mind. Okay. So why don't we just stop there? Okay. Thank you. Okay. So we have that, and I'm gonna give you that. If you want to know why that works out, there is an actual mathematical proof, like algebraic proof. I can post that online. I can find a video. I'm not going to do it myself. It's going to take a while to do that. We saw how long it took just to draw the graph. Okay. So for now, I'm just going to give it straight to you, and we're going to do things with it. So continue your notes, but I'm going to start writing out the notes. So let's give you an example, and let's mix a few concepts that we've already learned from the last lecture. So we're going to do y is equal to x squared sine of x. And we need to find, what I want you to find is dy of dx. What is that going to be equal to? You guys want to just try it for like a few seconds, just at like your desk? Why don't you take like 2 or 3 minutes at your own desk? Don't be afraid to actually ask someone next to you like where to start, okay? Try to figure it out. See if you can remember what steps to do. And then I just gave you that the derivative of sine x is cosine of x. Why don't we just give that a try? Good old college try, okay? Here, I'll give you the answer for you guys to check your answer to see if you're on like the right road, okay, the right street, the right road. Your answer should be x squared cosine x plus 2x sine of x. All right. How the heck did I get that? That just blows my mind. Okay. Right. Oh, what'd you say? Oh, okay. So maybe look back in your notes about the product rule. That is absolutely correct. You will use what's called a product rule, not the power rule, as Gray was putting out before, but the product rule. It's a little bit different. Raise your hand. Did anybody else get this so far? Ooh, Lisa, very nice. Oh, Sibra, what's up? Can't tell if that's a hand, Gwen. I'm not sure. No? No, not here. Okay, no, I'm just kidding. All right. I'd be in the same boat as you guys. Do not worry. This is not easy. So I'm gonna give it the good old college try myself. I would say I think most people would start with, I think this is just 2x to the first power, and that's the sine of x. I'm not really sure what to do with that. Do I add, I don't know, add sine? I don't even know. Okay, so I'm stuck. Is that where kind of most of you guys are right now? Like, or you guys figure it out? Not sure. Okay. Well, let's look at the equation. You don't have to rewrite it like I am. I'm just rewriting it just to keep the notes a little bit more cleanliness sake. Okay. Can you take the derivative of x squared? If I gave you just x squared, can I take the derivative of x squared by itself? Yeah. What if I gave you sine of x by itself? Can you take the derivative of sine of x now? Yes. If you have two components that are like right next to each other and they're differentiable, then you pretty much have two components that you could take the derivative of. You have to use the product rule. The product rule is as such. If you have the derivative, if y is equal to two components, u is a component that could be, you can take the derivative of. V is another component you can take the derivative of. What you're supposed to do is you're supposed to do like u times v prime plus v times u prime. The primes mean you take the derivative of v and you take the derivative of u. So what would that look like here? Let's first define x squared as u, and let's define sine of x as v. I'll color code it, okay? You don't have to, but hopefully that'll make it a little bit easier. And then let's say our first step that we saw was u times v prime. So u would still be the same, x squared times, what is the derivative of sine of x now that we know it? It's, what is it? It's the cosine of x. Look at that. Crazy, okay? And now we just add that to v times u prime. Well, I'm mixing up my caps here, okay? So the first component is v. Right, I'm going to color code that to v. So my v is sine of x. And then what is that going to be multiplied to now? Yeah? Anybody got this one? 2x. Very good. Very good. And is that not just like what I had here for the answer? That's all you have to do, right? This is what I call my Slurpee answer, because you can get the different colors, the blizzards, right? Like the cherry and the blueberry. Beautiful, beautiful Slurpee answer. Okay, I'm going to give you an example. And I want you to do this now on the whiteboard, okay? Do not stay at your desk. I want you to find a space on the whiteboard to do this, okay? And here's another rule, okay? Here's another thing. I want you to switch partners, okay? I do not want you working with the same person. Find someone else across the room, okay? So if you're in the middle, just find someone, okay? But I want you to at least work with one other person. So you cannot lone wolf it today, okay? So here's your first problem. It's going to be, you're going to find m is equal to cosine of x over 1 minus the sine of x. And then I want you to find dm dx. That means just find the derivative of m is equal to this, okay? Be careful. This is not multiplying to each other, but they are both differentiable components. What rule do you use? Okay, please find one partner that you've not worked with, okay? And not at the same table. You got to crisscross. I don't know, crisscross. Like different tables got to interact, okay? All right, please turn on the lights. Stevie, get the lights. Just reach out and grab someone and be like, you're my partner. Goodbye. Let's see if we have an odd person out. Stevie, you are with Sean. There you are. Yeah, sorry. Greta, you're with Elena. Looks like that's good. Yep. Elena and Greta, you guys are partners. Sorry, I'm just gonna put you guys together. Risa and Gabby. Okay, you two are fine. It's fine. Yeah. Yeah, what's going on, Brenda?
Like I got the I know what a common but I just don't remember the box, like the arrow. Exact zeros.
Go to 0. That's the option. Yeah, that's cool, man. You have a good memory. You have a good memory of boxes. That's not easy to memorize. So. Very good. Nice. I'm seeing the right rule. Nice. You guys are insane. This is great. This is really good. Do you guys want the answer so you know what you're working towards or no? Great. Is that enough? Yeah. Be very careful. A lot of things cancel out. So
And then sine squared x, like cosine squared x. And then we can turn it.
I'm just gonna let you know. You get a once you simplify everything, you get a really nice, clean answer. Not super clean, but clean.
So he has no cosine squared of x is sine squared of x.
Okay, so you guys have this. What did you first define? What is your?
This is gonna be positive.
So use
That.
This is the only way that logic makes sense.
Oh.
And this is gonna be negative.
Oh, okay. So let's just do the derivative of that by itself. What is the derivative of
We're left with
0 minus? What is the derivative of 6? Yes, it is. That is your derivative.
going
Of so that's b prime. So that's b prime.
just like saying
When they're adding and subtracting, that's fine. But it's only when they're multiplied, like right stuck to each other, that's when you're so you're probably pretty good. That's a common misconception. Okay. You guys said okay.
I was attacked by.
hey.
it's just
Yeah, you got it right. That's
That's just something
Oh, sorry. Do you recognize what that is? Sine squared of x plus cosine.
I thought that these negatives were mixed.
Okay. You have 1 minus sine of x.
It was like
Based on what made sense.
isn't the derivative cosine x minus sine x?
Another way to say that is, hey,
I don't know.
on a roll right here. Okay. There you go. Okay. Is that difficult? How are we doing? No, you're good. Where did you get x sine x squared from? Oh, okay. So that's a, sorry. Oh, I would suggest, I know this is not really fair because I won't really expect this, but leave it like that. Leave it this way, and then let's see, 1 minus sine x squared. And then, let's see, this is the part that didn't really say you had to.
Oh yeah. I mean, going from linear to linear to pre-calc was like the
Just do. Oh,
Yeah,
you had this here?
just repeat it
Just did
with a
right here.
little bit more.
Same thing. Sorry.
And
Yes,
someone's
very good.
everything's you missed out. Yeah, a little bit.
Yeah, the derivative of sine x should be.
You have to have three. Recommended. You have to have.
So you had 1 minus sine x, right? And then the derivative of that was 0 minus.
Because I took
You still have minus.
very. I took
You see what I'm saying? So that's probably where. So this should have been. Okay.
Integrated three.
I think it was just a.
Recap.
But you got the idea.
sophomore.
Right. Mr. Romero,
I see
intellect.
that
Okay.
for you.
This is good. This is not easy. Okay, quick notes. All right, so that's what you should have gone. 1 over 1 minus sine of x. One property that I did not go over that I guess I implicitly expected you to just know. Sine squared x plus cosine of x, cosine squared x is equal to 1. Okay? You don't need to write that down, but maybe make, or if you want to make a, like, put it in a box and put like a side note or something to just tell yourself that this is not necessarily like a step that you have to take directly into solving this, but you do have to know this at some point to substitute in 1. Okay, so it's a side note there. That's a little property that you have to know. So here's the solution. You take the dm, or like you take the derivative of m with respect to x. So I made my u, or my cosine of x, u, and then my 1 minus sine of x, v. Okay, and then the first step was I did v times u prime, and I believe this is u times v prime, and that's v squared. Okay, so v I left alone, 1 minus sine of x times the derivative of cosine of x. So I wrote it in this notation, minus cosine of x, which is u, times v prime, which is the derivative of 1 minus sine of x squared, or of sine of x, I'm sorry. And then I just took v, which is 1 minus sine x on the bottom, and I squared that. The main part here on the top is u prime. The derivative of cosine of x is not minus sine of x, okay? Minus the cosine of, and then I actually took the individual components. The derivative of 1 is 0, and the derivative of sine of x is minus cosine x, okay? Because it's already being subtracted, minus sine x. The derivative of that sine x is cosine of x, but it was already originally being subtracted, okay? And you keep that there, 1 minus sine of x squared. I didn't expand that. I would suggest in the future when you do these type of problems that are quotient properties or quotient, you use the quotient rule. That's what you just did. Okay. I would leave the bottom unexpanded. So don't multiply it out into a 3-term polynomial, meaning like, that's 1 squared minus 2 sine x plus sine of x squared or something. Like that's what you would have gone if you expanded this out and you foiled it out, if you remember what I'm talking about. Okay. I don't want you to do that. Try not to do that unless you have to. So again, v prime on the bottom, try to leave it unexpanded, okay, in the future. So, okay, I should have listened to my own rule. Okay, so that's not correct, right, what you see on the bottom there. Should have written it as 1 minus sine of x squared, okay. And then this last step is you should have had a minus sine of x. And so sorry, let's backtrack here. I distributed this minus sine x both into here and here. So you should have gone minus sine x times 1 is negative sine of x. Negative sine of x times negative sine of x is a positive sine squared of x. And then in here, same thing, cosine, I think it's cosine of x, I'm sorry. Cosine of x times 0, 0. Cosine of x times minus sine, or cosine of x is, that should be a negative cosine squared of x, but then it's already being subtracted. So you have this statement here, sine squared of x plus cosine squared of x. That's where that property, that side note we kind of talked about, comes in handy. We recognize that if we were just left here, nothing really cancels out. Okay, so that's where you start digging in deep for stuff that you do know at this last step. Okay, can I simplify it any more? Okay, and yes, you can. Sine squared of x plus cosine squared of x is equivalent to 1. So you'd rewrite the whole thing as negative sine of x plus 1. You can rewrite that as 1 minus sine of x. On the bottom, conveniently, that is 1 minus sine of x squared, which if you don't understand, that means 1 minus sine of x times 1 minus sine of x, basically by itself, or to itself, I mean. And you can simplify and cross those out, and then you'd be left with 1. That simplifies to 1, because if you have it in the numerator and denominator, they will cancel out, and you're left with 1 over 1 minus sine of x. Okay? Any questions? No? Okay. I'm really happy about that kind of interaction you guys had. It seemed like it's really nice that you guys talk to each other. Okay. Hopefully we can do a little bit more of that soon. For the time being, write this down. Derivatives of the other trig functions. Now you know sine of x. Now you know cosine of x to take the derivative of them. What about the other ones? How many other trig functions do you know of besides sine of x and cosine of x? What else is there? Tangent. What else is there? Those are the 3 main ones. Think about the inverse. What are they called? Do you remember? Cosecant. What else? Does anybody else remember the other 2? What did you say? Yep. Cotangent, cosecant, and secant. All right. These are reminders about what those are. Tangent is another way of saying it is sine of x minus or divided by cosine of x. Hint, hint. If I write these out explicitly, you might have to use those properties. In the same way, sine squared of x plus cosine squared of x is equal to 1. You might use these facts that you know of. Tangent of x is also equivalent to sine of x divided by cosine of x. Can you imagine the possibilities of your derivatives, knowing that tangent of x is also a quotient of sine of x and cosine of x? The possibilities of hard, crazy, difficult, engaging, though, math on your own are endless at this point. This box, the reason why I boxed this is because this is the meat and potatoes of the stuff that you want to know, the new stuff that you've not seen. The basic trig functions are just reminders of what you've been exposed to. I'm not going to say that you should memorize. It's hard to memorize these things, okay? But I'm going to say that you should at least recognize Memorize versus recognize, right? I do recognize these guys, but I don't recognize these guys. That's why I boxed these. These are new. I know this is very hard to see, but the derivative of tan of x is equal to the secant squared of x. Again, the easiest proof you can do to prove that to yourself would be to graph it, but that would also require you to understand that, or require you to understand the graph and the way secant looks, and not only that, what secant squared of x would look like. Okay, you can also solve this or prove this to yourself algebraically as well. But for now, for the interest of time in my class, we're not going to prove it algebraically. It could take up to half an hour of just explaining. Is everybody good copying all this stuff down? I'm going to launch right into an example right away. Again, conceptually speaking, nothing new today. We're just taking derivatives of the other tan or the other trig functions, right? All right. Are we good so far? Yes? No? No? Yes, Gray.
I have a question. I was going back a little bit.
Uh-huh.
Earlier you were talking about the derivative of sine and cosine.
Yeah.
On the notes you wrote down that the derivative of sine of x is negative sine of x, and that the derivative of sine of x is cosine of x.
Correct.
But I was just kind of confused because we were looking at
the problem
graph of sine of x, and it looks like it was negative.
So here, let's see. All right, so let's go back.
Oh, there it is.
Yeah, I think you know what it was. I think this one was incorrect. Do you see that?
Mm-hmm.
This one is correct. That's why I showed you. You have a good visual memory, though. Yes, there were two contradictory images that you did see, but the latest one, this bigger note card that I wrote the answer on, is more correct. Is correct, okay, in comparison to the other one. So, but you do recognize that that's a positive cosine, right? Okay, cool. Just making sure. My mistake, so I do apologize. But it still stands. The derivative sine of x is cosine of x, positive. Okay. All right. Let's do an example now. You guys are gonna love this, every little bit of it. So today is just a lot of practicing with these derivatives. But this is also a slightly different type of problem, so be careful, right? Very careful. Let's give you that the f of x is equal to tangent of x divided by x. So who knows what this function could be? This could be a function that represents how your business is doing financially. Who knows? If you want to graph and see what the curve looks like, we can do that, okay? We're going to find equations for lines that are A, tangent, and B, normal to the graph at x is equal to 2. Do not be frightened. I'm just going to move this over to the right, this window, but the notes are still going to be there, or I'm sorry, to the left. The notes are still going to be there for you to see. Oops, sorry, as I promised. This shall stay on top. Let's engage this really quick. Let's keep this window on the top. Heck, come on. Sure, yeah. Okay, we'll keep that on the top. Then we'll go to desmos.com. Let's reiterate what this type of question is asking, okay? besides just launching into like memorized math. I want to actually go through what you're actually doing. So we're gonna graph this really quick. I don't expect you to do this for the problem, but I just want you to get the point of what we're doing. Hopefully a lot of you guys are like, this is redundant and I already know what we're doing. That's great that you're at a point where you understand what's going on, okay? But I'm speaking to those like myself when I was younger that didn't quite follow and I just did math just to do math, okay? Yikes. This is tan of x divided by x. That's what the graph looks like on the right. So let's see oh boy, where's 2? Okay, so I guess approximately, I guess it's somewhere here. All right, so right around at x equals 2. Don't highlight this, but highlight this. Okay. Okay, so this is going to be bad for the people at home, but I'm going to pause this, freeze frame this, so people at home won't get this effect, okay? But you guys will. So at x equals 2, for this graph here, we're going to find the equation for this. So tangent, what does that mean? What does tangent mean? If you're tangent to this curve, what does that mean?
It's a line.
What? Yeah, did you? All right. You had such good hand movements that you don't want to be like, oh, okay. All right, go ahead, Stephanie.
It's a line with a slope that has the same slope as that point is.
Okay, so at this individual point, it's got like a slope, right? It's got like a really steep slope. And when you're tangent to something, that means you're touching it only at one point. So we're trying to find a slope of a line that touches just that, sorry, you know what I mean, just that point, right at that singular point, okay? In order for you to do that, your slope of this line has to match the slope at the actual slope at that line. So the slope of this tangent line has to match exactly what the slope of this individual point is. That, okay? So that's tangent. What's normal mean in comparison? So this is tangent. What does normal mean? So,
The perpendicular, the line that's perpendicular to that.
okay, so yes, so this slope here is tangent, right? When I ask for normal, I'm asking for the line that's perpendicular to this one. So I should grab another meter stick. And if you are putting things together, the derivative is the slope at that tangent point, okay? So you've been doing that. You've been calculating the slope this whole time. But you need to find the equation for this whole line. If I'm asking for the normal line, I'm asking for this. Okay, does everybody see that now? This line, the equation for this line. It's very similar, but what can we say about the slope of this guy when compared to this guy? It's the negative reciprocal. It's almost the exact same thing, but it's flipped on its head. Okay, well, it's flipped like a fraction, and then you add a minus sign to it. Okay, but let's take it step by step. So we need to find the slope of the tangent line first. All right. Okay. So first things first, we need to find the slope. We need to find like a general slope formula. So what I will do is I will take the derivative of f with respect to x. That means I have to take the derivative of that guy. And that will only give me the slope. So if you remember my graph, I think, you don't have to draw this, but remember on my graph, I just want to find, so I'm trying to find the equation for this line right here, this dotted line here. I need to find the slope of that. In order to find that slope, it needs to match the slope of this guy. And f of x was equal to tan of x over x. But I need to find the slope of that guy, the slope is equal to df of dx. That slope of this dotted line has to be df of dx. That's what I want you guys to do. You need to find the derivative of f with respect to x. Again, let's do this exercise again. This time pick a new partner, again, that is not at your table, right? So please get up, find the derivative of tan of x divided by x, knowing what you know here. The derivative of tan of x is equal to secant squared of x. This is good. This is what makes this class an AP level class. This is brand new stuff. So you guys gotta get to it. Jump right into it. Okay? I'll wait for Mr. Lee to- What's going on, Brennan?
You know how long I have to take the test?
You have as much time as you want. You just gotta mind.
My calculator was crazy. I don't know what.
Do you have programs on there? Or do you want me to
Yeah.
That's up to you.
Someone said, "Here, I'm gonna put this on." And I'm like, okay.
Let's slow everything down.
That's like everything.
Okay, so in the future, if you ever get to a point where graph is not working, you don't know what second to change, put second, and that plus sign is memory. You're gonna go down to reset. Just reset the whole computer. This stinks of you're really good at programming. You can program awesome programs. But you don't really care much for that. You reset all around. Say, yeah, reset it. And now everything should be my hope is yeah, no worries.
Wait, how do you reset it? Because my calculator at home is being weird.
Yeah, okay, so
I don't have my calculator with me, but it's being weird.
I know, but here's the thing though. If you have any cool programs on there, you don't use it.
I don't know anything about programming.
So you and I are in the same boat, right? You're gonna go to if you have a TIA here, okay?
Yeah,
Okay. Just making sure. Some people have
I just had the one that they have.
Oh, okay, great. This is like a big standard. I don't like this is no technical. Anyways, press the second you press the plus button. That's MEM for memory. Okay? You're basically clearing the RAM of the memory. You're gonna reset, and then you say all of it's gonna be reset back to the factory setting. It's gonna ask, are you sure? Or yes. You have to actually deliberately go down the number to say yes.
Oh, so that's yeah.
That's it. And everything should, so some people have like everything looks fine and they try graphing, but it's just something that the previous user set that they can't do. It's just error. Not just getting me wrong. Okay? And I still can't graph it. This usually results in it. Okay? Yeah. So just let me know if you
On that screen, and this is 2018, and they're charging $100.
that's what I'm saying. There's an
For
actual
$100, they can get much better.
Yeah, I'm glad you said that, but right? So it should be seamless like a I have a now mine's
I'm not asking for an iPhone,
yeah.
but I'm asking for a decent screen.
Yeah, they still charge like $100, right? So for I know people that have droids don't have to worry about paying. I have an iPad, so like I had to pay $10 for like a nice program, and it emulates the TI-84. It's great. It looks just the same. But when it comes to the graphic, when I graph it, it's like way better. You can actually do it. It's just you can't use it on anything else.
Well, I just took the SAT.
Oh, you're great. All right, cool.
I'm all set.
So when you're in college and you're in class, you don't have to bust this out. You can just bust out your phone and buy that program. Okay. No, I'm just kidding. Yes, you can. Just kidding, man. Good. Okay. Oh dear, I'm not kidding. That might be the actual rule. You are, sir. All right, let me write down the answer so you can check to see if you got it right. It won't be nice. It's not nice looking.
But I mean, you don't have to. Yeah.
Whoops. I know it's hard to see. I'm so sorry. Yeah, you do not have to make this really nice looking. Is that what any of you guys got? Did any of you guys get that? If you got that, you're good. No, 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 I do not. No. All right, I'm gonna.
Where? bottom?
How did I get what?
Oh, for the slope of the
That's
line.
not
Oh, let's see.
Shouldn't that be?
Because this is a.
Oh, well, yeah, I know it starts that way, but I can't get down to just a single x to the first power and keep the tangent.
Oh, whoops. On the. Let me see. Hold on. Let me see.
Be an X squared, right?
So I could start doing it. So I got. Yeah, this is the final answer, but I'll show the steps for how you're supposed to get it.
That's the derivative. That's not the
So on. This is U. This is V. Oh, no. I'm confusing you. Sorry.
And shouldn't it be X squared?
Yeah. I'm sorry. Yes. Sorry. That's what you were saying, Gray. How did you get the bottom to the? Sorry. So super sorry. Okay. Hey, inadvertently made you guys a tad bit more engaged, but not deliberately. I wish I could say it was planned, but it wasn't. Okay. I'm not that good at this. Okay. Let's see where we are. That's good. That would be the next step. That's correct. All right. Please shut off the lights, Stevie. Stevie. I'm just kidding. All right. So that's beautiful that you guys found this. I only gave you that component to do. So does that mean we're finished with this?
No.
Okay. So the thing is, I asked you to find me the derivative of this guy. What you now have is an equation where you can find the slope at any individual point. At what point do we want to find the slope though? At x equals 2. It's asking me to find a equation for a line that is tangent to that point, meaning the slope had to be the exact same as at x equals 2. This line, in order for it to touch only once, has to have the same slope as the derivative or as x equals 2. Okay, so we have the slope. The slope is at that individual point df of dx. It's this equation. This is df of dx. But now we're going to find that slope at that point. So you will be required to use your calculator here. So let's put in x equals 2. So step 2 should be putting in, you know what? I'm going to change the notation a little bit for you guys. Okay, you're finding it's the same thing. This and this mean the derivative of f. Okay, but the derivative of f at 2. So that's going to be 2 times secant squared of 2 minus tangent of 2 over 2 squared. Okay. For the interest of time, can someone just tell me what they got if they're putting it into the calculator? Gray, what'd you get? And then Gray, were you able to get an answer? Don't worry about it. Yeah. So yeah. It is 3.4. I got 3.433. Okay. That's just the slope. All right. And then remember, this is a linear line. So if you remember, what this will be equal to is y minus y1 is equal to m times x minus x1. That is the equation for this dotted line. What we have just found is the slope, which is going to be our m component. Okay. Number 3 is let's just pick a point now. This is the kind of the cruddy part here is we need to pick a point x1 comma y1. I'll just say this for convenience sake. You have x equals 2. Why not just find that point there? Because guess what? That's the only thing you could really plug in. We need to find a point on this line. Not this line, but this line. But remember, this line is tangent to this curve at x equals 2. So why don't we just use x equals 2? I don't know of any other coordinate point on this line, so just use whatever it's tangent to, x equals 2. How do we find y1, though? How do we find?
Plug it into the original equation.
The original equation was f of x equals tan of x over x. So let's reiterate that. F of x is equal to tan of x over x, which is otherwise known as y if we're doing an xy coordinate. Okay, we're specifically finding f of 2. So plug in tan of 2 over 2, and then you should get negative 1.093. Again, that is not your slope, but this is your y1. Just to reiterate, I'm sorry, that's negative 1.093. Finally, all you need to do is put all the pieces together. Y minus y1 is equal to m times x minus x1. This y and this x stay constant. Okay, they just stay as y and x to maintain the linear function or the linear equation, the equation for a line is what I'm trying to say. Y1, though, you can actually substitute with negative 1.093. M is not going to be a great sleek number, but is 3.433. And then you can substitute in x1 for 2, okay? Because we're looking at 2, or this whole thing, this equation at x equals 2 on this curve, okay? And then you can leave your answer as y plus 1.093 is equal to 3.433, x minus, not sure what this is, 2 times this, that's like 6.866, I guess. You can leave it as that. You could even leave it as y plus 1.093 is equal to 3.433 x minus. You could just leave it like that. Or you can simplify it even further by subtracting 1.093 from both sides, giving you 1. So these are all the same. I would accept any of these as your final answer, okay? Y is equal to 3.433x. I actually don't know what that is. 6.866 minus 7.956. Thank you. Yep, that would be another answer as well. This, or this are all acceptable answers, okay? So that is only for part, For part A, that is just the line that's tangent. So guess what? That means on my video, I will go over part B, what part B will look like. If you can already imagine it, you just take this slope and you find the negative reciprocal of that. So that will look like negative 1 over 3.433 as the slope. And then you just plug in this point. I'm just going to stop right there, okay? I got a little bit more to go on the video as well. So I got this problem, and I got like one more concept for you guys to go through on the video, okay, for the chain rule. And we will meet back next week. You guys have a great day. Thank you guys for coming to class, okay? Please watch the videos, because next week I will expect you to know what the chain rule is. Yes, Risa.